In this video, we're going to be taking a look at the QIDI PLUS4 3D printer. And this is by no means a new model. It's been out for quite some time now, and I've had the opportunity to spend a few months with this printer before making this video for you guys. In the past, I tested their X+3 model, and I liked that one so much that I personally bought 2 more of them. So I've got 3 of those, and they're still here, they're still operational. I use them on a fairly regular basis, and because I like those ones so much, I'm expecting pretty big things from the Plus4 model. Now you can of course check the QIDI website for all of the technical details of the Plus4 model, but some of the highlights include the fact that it is a Core XY 3D printer that's fully enclosed. It's got all of the modern features that you would expect, such as input shaping, auto bed leveling, and more. It's got a 305 by 305 by 280 millimeter build volume. It's got an active heated build chamber that can reach and maintain 65 degrees Celsius, and a nozzle that will go up to 370 degrees for printing more advanced filaments. And if you've been paying attention to the QIDI brand, you'll know that more recently they did release their QIDI box, which is their multi-material, multicolor unit that is fully compatible with this Plus4 printer. Now they did send me this printer before the release of the QIDI box, so I don't have that. We won't be looking at that in this video, so we'll be only doing single colored prints, but it's just nice to know that it's out there, it's compatible with this machine, and it is now available for purchase. So with all that said, let's get started. We'll begin with the unboxing, and the QIDI X+4 is pretty heavy, so we're going to have to start the unboxing right here on the floor. And when you first open up the box, you'll notice that there is a USB stick on the side, don't miss that, and then you'll find the top glass underneath. Next, you can remove some of the protective foam, and you'll find a sticker showing you how to lift the machine using the handles on the top of the printer. And once you lift that whole machine out using those handles, underneath you'll find a couple boxes of accessories. And then you can haul this thing up onto a table and you can start to remove all of the protective film, keeping your beautiful new 3D printer safe. But before we can get into the assembly and setup, we do need to remove a few screws that were being used to hold things together during shipping, and to do that, 32-piece compact screwdriver set that you can find on my website, embracemaking.com. It's perfect to keep on hand for working on your printers, and it is adjustable, and the bit holder at the end is magnetic. So we're going to use this thing to remove these 4 socket head cap screws that are holding the print bed down during shipping so that it didn't move around and get damaged. Once those screws are removed, you can just put them aside. We're not going to be using them again, and there are these plastic brackets that can also be removed, and those also get put aside as they will not be used again. Then you can move up to the gantry, and there's a bunch of zip ties holding things together. You can cut those off and remove the cardboard protective cover off of the print head. And there's also a piece of tape holding down the cover for the carbon filter that is wrapped up in a bag. So you can remove the filter, you can remove the bag, and then place it back in the filter holder and slip it into the back of the printer again. Inside of the accessory boxes, you'll find things like the spool holder as well as the power cable, a little bit of sample filament, as well as a small toolkit, some glue, the touchscreen, which we'll be installing momentarily, and some other small odds and ends, spare parts, and a print bed scraper. And now with everything unpacked, we can get into the assembly. Now there's very little to do here. Most of the printer does come pre-assembled, but on the front, you'll notice that the door is missing a handle. So this also comes in the accessory kit. There's a couple screws there. They go through the holes. You'll find that there are some grommets that protect the glass from the metal screws, and just screws into the back of the handle, and you've got a nice, beautiful aluminum handle in the front of your machine now. Up at the top of the printer, this is where we need to install our touchscreen. And once you have your touchscreen removed from the packaging, you'll notice that there is a connector on the back, and this corresponds with the loose wire connector coming out of the top of the printer, and you can just insert that into the receptacle. And you'll also see that there's some tabs on the back of the touchscreen that correspond with slots on the printer, and you can insert that screen and slide it over to the left-hand side to lock it in place. I did this upside down. Later on, I'll show you the correct way to do it. We can also insert the power cable at this point, and then at the back of the machine, there are 4 screws that you can remove, and we can grab our spool holder from the accessory kit. You can take it apart. There's this bracket here, and we're going to be inserting those 4 screws into this bracket. And one side of the slotted end of this bracket is open, and that's going to face upwards. And once you got those 4 screws back in place, you can also take the spool holder peg and you can install that like so. Now the end of the peg has this removable piece that twists off, but you really shouldn't need to remove that when you're inserting and removing spools. And this whole assembly can get inserted onto that bracket simply by sliding it into place. Now in one of the accessory bags, there's a small piece of PTFE tube and it fits into this fitting at the back left-hand side of the printer, and it just presses into place. And when looking at the printer from the back, on the front side, you'll notice that you'll see the camera, and there's a small protective piece of tape that can be removed. And finally, we can place our glass lid on top, power up the printer, and as I had mentioned earlier, I did install this screen upside down, so you'll see that I can just remove it by pushing it off to the right hand side, flipping it around 180 degrees and making sure that the wire is pressed into the wire channel, and reinsert it and push it back towards the left hand side of the machine to lock it in place. When powered on for the first time, the touchscreen will walk you through the initial setup. It's going to ask you if you removed those screws, which we already did from the print bed. You can select your language, and then once that is done, the print bed will home itself to the top of the machine, and it's going to ask you to load in some filament. I'm just going to put in some generic PLA at this point. You'll see that it slips over top of the spool holder, and you can route the filament down through that small piece of PTFE tube and push it all the way to the print head. And once you have the filament all the way loaded into the print head, you can just click the check mark. I'm setting it to 230 degrees, and I'll hit next. And once the nozzle is heated, the extruder will start to pull that filament in and prime the nozzle. After that, the printer will go through the rest of the setup, including input shaping as well as print bed leveling. During the auto bed leveling process, I'm going to set the bed temperature to 60 degrees, and that's just because that's typically what's going to be used while printing PLA, which is mostly what I'll be doing. And then the printer will take over and do the rest, and it'll probe the print bed and do the auto bed leveling. And at this point, one of the things I'd recommend doing is familiarizing yourself with all the controls on the touch screen. So at the bottom, you can see that there's a home tab. Next to that, there's a control tab where you can control the various heating elements, such as the hot end, the heated bed, as well as the heated chamber. This screen is also where you can initiate filament changes, such as loading and unloading filament. And that will, of course, require the nozzle to be heated up. And then the touchscreen is intelligent enough to walk you through the rest of the process of feeding in new filament or removing filament that you want out of the machine. The Home tab is where you'll just find a general overview of the entire machine, and you can control things like the internal LED lighting. And you can also click on the Wi-Fi icon and set up your Wi-Fi connection. But you can also access these options from the settings tab, so that's the button on the bottom right hand corner where you can see you can change the language, all of your network settings, also checking for software updates which can be performed over the air. The middle tab, which is the documents tab, this is where you're going to find all of your printed files. There are some that come preloaded on the machine, but there's also a tab at the top that says USB, and this is where you'll find all of the files that are loaded into the USB that you've obviously inserted into this printer. So now that we have the machine set up and we've got a good handle on all of our controls on the touchscreen, we can download and install Qidi Studio. This is Qidi Slicer, and it should look familiar to you if you've used other slicers such as Bamboo Studio, Prusa Slicer, pretty much anything that's been forked from Orca Slicer. It seems like these companies have kind of settled on a standard at this point, which is great, and they're more or less customizing the user interface and all of the profiles within. So we're going to go ahead and select the X+4 up at the top left-hand corner of the screen. And you can see for my filament profile, right now I just have a generic PLA set, and I'll import this model here. And this is just a bracket that's going to hold one of my Google Nest Wi-Fi points. And I think it would be a pretty good first print to get familiarized with this machine. And I'm only going to make a few small changes to the print profile here, which is the standard 0.2mm PLA profile. So I'm going to increase the walls to 3, and I'm going to increase the infill density to 25%. And I have a preference for triangular infill, so I'm going to select that. Then I'm going to slice this model by pressing the slice plate button in the top right-hand corner of the screen. We can get our print preview, and everything looks pretty normal. Again, if you're not new to 3D printing, none of this should look new to you. Now I'd like to send this off to the printer wirelessly, and to do that we need to connect our device. So there is a device tab up at the top. We can click that, we can add our printer. Now in this case you can see that you can use the arrow button. I've got X+4 selected, and that should be because I've already selected that in the prepare tab. I'm going to type in the IP address, which I could find on the touch screen once I've connected to my Wi-Fi network. Now I have not had any luck with this. Unfortunately, my Google Nest Wi-Fi sometimes is a little weird. It does have a 5 gigahertz and 2.4 gigahertz band, and I'm not sure which one the Qidi prefers. Some printers will only connect over 2.4, and I've tried even setting up a guest network which is isolated to the 2.4 gigahertz band, but that didn't seem to work either. So for the duration of this video, I will be printing off of the USB stick. So all I've done in the slicer is just exported the G-code file to the USB stick, plug that in, and then on the touchscreen, head on over to the document tab, click on USB, and then find my file and click print. And again, this whole process is very standard. There's nothing unique about this to the Qidi, and the touchscreen is just a different user interface if you're coming from a different brand that you'll very quickly and easily get used to. For the most part, it's very intuitive and straightforward. The first print in this gray PLA seems to be going down very well. The first layer is looking great, extremely uniform, and no signs of the nozzle being too close or too far away. I've been testing and reviewing printers for quite some time now, and it seems like gone are the days where you would be developing your own print profiles. All of the profiles that have come on the machines that I've used recently have been very good, and all of the automations that are now standard on these machines, such as input shaping as well as the auto bed leveling, are very reliable, and they've been working great. The Qidi PLUS4 seems to be no different in this case. So far the print profile looks very good, although the one thing that I do find that you do have to tweak from time to time on some of these machines is the part cooling. Now you can see here that on some of these extreme overhangs they were not looking very good, so I'm going to go ahead and cancel this print, and we're going to hop back into the slicer, and I'm going to show you guys how to fix that. Most of these cube frame enclosed printers these days come with auxiliary fans that are on the inside of the machine that blow across the print bed. And I noticed on this part that the extreme overhangs over here were the problem. So I'm going to rotate this part so that that area is facing the right hand side of the build plate, and that is in the direction of the auxiliary part cooling fan. Then in the filament profile settings, I can go to the cooling tab, and if I scroll down, this is where you can see where you can control the auxiliary part cooling fan speed, and I've set that to 100%. And just to be cautious and potentially prevent any curling, I've also set no part cooling for the first 3 layers. Then I'll reslice this, I'll save it to the USB stick, and we're going to try this again. Now I did find it a little odd that within the generic PLA profile within Qidi Studio that the auxiliary part cooling fan was defaulted to off, as PLA does generally respond pretty well to part cooling and there's not that much risk of it curling. So if you do get this machine and you're setting up your own print profiles, I would probably save this as a custom profile and just leave that auxiliary part cooling fan on, at least to some degree. And you can see here that it completely solved that problem of the ugly overhangs, and this part looks very good overall. The first layer was perfect. The overhangs were looking quite good, although around this bridge area here, it could look a little tidier, but to be fair, this geometry here is actually very awkward to print as it seems like an extended arch. So I think it's more than acceptable considering that there was no support, and the rest of the part looks good, including that Google logo. Moving on, we're going to try some other pieces here, and these pieces will be part of the same assembly for this Google Nest Wi-Fi access point holder. I'll quickly arrange these 2 brackets on the build plate inside of Qidi Slicer, and you may notice that when viewing these things from the top or any angle, there is a perspective view, which you can turn off by going up to the top and going into File, View, and then Use Orthogonal View. This is my personal preference inside of a slicer, as it makes things much more easy and accurate to place on the build plate. I'll be using the same filament and print settings as the previous example. Just of course in this case, the geometry itself is different, and we'll be looking at some of those different features. And since I'm printing everything off of the USB stick, one thing I noticed and I want to address here is the touchscreen itself. It feels very good and it's very responsive. However, there is one circumstance in which it appears to be a little bit laggy, and that is when it is loading the print preview or the graphic for each of those G-code files. This is something that appears to have carried over from previous versions, such as the X+3, which I own 3 of those machines. So I think it's firmware related and actually not related to the quality of the screen or the hardware itself. Now looking at the prints, these things turned out looking very good. Of course, I had the auxiliary part cooling fan activated for these prints, and you can see that the overhangs in this dovetail joint turned out amazing. Now, one thing I did notice on some of these prints, and we'll talk about this a little bit later, so keep watching, there is some Z-banding. I'm not sure if that would be what this actually is, but there are artifacts on some of these prints that run horizontal or parallel with the print bed. It's more obvious on some part geometries as well as with some filament colors. And this is something that you're going to see in a lot of the prints that I'm going to show you up until a certain point. And again, keep watching because I do have a fix for this, and later I'll show you what had happened and how I got it resolved. But beyond that, everything else looks reasonably good. Even the top solid layers also are quite smooth. You can see some markings from the nozzle passing over, but overall, I'd say these are some very good and impressive prints. Now I designed these parts to fit together, and you can see that there is a dovetail joint, and I designed them with a gap of about a 0.25 or 0.3 millimeter gap around all of those faces, and you can see how easily the two parts slide together. Now, this doesn't necessarily mean that the two parts are dimensionally accurate because I'm not actually measuring them to confirm their dimensions, but with respect to one another, it looks like the dimensions are at least repeatable, and you should have no problem with parts that are intended to fit together as long as you're printing them on the same machine. Now, at the back of the Qidi X4, there is a filament poop chute. And this is where the filament purge falls out the back of the printer. And when this printer was first released, there was no multi-material unit, but more recently, Qidi has released the Qidi box, which is a multicolor, multi-material unit, which allows you to print up to 4 different colors when connected to the Plus4 machine. And all of that purge coming from the nozzle will go out the back of the printer, and currently there's no way to capture this. So I'm going to print this poop chute and bucket. Now this is not my design, so I'll link to this in the video description down below, but you'll see that using the standard print profile, this is going to take about 8 hours to print. Now it takes up most of the space in the XY direction, and it's quite tall, so it almost uses up most of the Z height as well, and it's a very long print. Now if we go ahead and change to the draft profile of 0.24 millimeter layer height, surprisingly, you'll see that the print time has actually increased. The total print time in the draft mode is now 8 hours and 30 some odd minutes, so it doesn't really make any sense to me to use something like the draft mode when you're not saving time. There's even an extra draft mode of 0.28 millimeters layer height, and that doesn't seem to save any time either. So at least for these prints here, this does not seem to make any sense, and I'll go with the standard print profile. In those draft modes, it's more than likely that there is a volumetric flow limit that is limiting how fast the printer can actually print these parts, and therefore at the taller layer height, it's slowing the print down and you're not saving any time. And for this model, we've got a lot of overhangs, so in the standard print profile, I've just verified that the auxiliary part cooling fan is active. And then again, I'll be saving this G-code file to the USB stick and printing from the USB stick on the Plus4 machine. This print is being done in the same gray PLA that we've done the previous prints in. And while this is printing, one other feature of the Plus4 machine that I want to quickly discuss is the fact that it has a finer belt tooth pitch on the Core XY system than some of its competitors. So that means the teeth are closer together on those Core XY belts. And this could or should at least perhaps lead to less VFA on the surfaces of these prints. I've seen some other guys do some deep dives into this topic on YouTube for this machine specifically and comparing it to some other 3D printers in the market. And I'm not going to go into great detail in this video on this feature here, but go check those out as they are found on other videos from other channels on YouTube. This 8-hour print finished without any issues whatsoever, and for the most part it looked very good. The gray filament does a moderate job of hiding print imperfections, but if there was anything severe or major, you would definitely be seeing it at this point. All of the walls looked very smooth with no signs of ringing or ghosting as the print head changed directions along some of those sharp corners. And as you can see, most of these walls were built up off of that change in direction that happened on an overhang, and I would say that overhang is about 45 degrees. And you will have noticed as I was taking those video clips of the part being printed that there were no supports necessary on this part. Now on the walls near the bottom, this is where we will find some of those artifacts that I had mentioned earlier. But in this part here, they seem to have gone away as we move up the part about, I'd say 3 or 4 millimeters, and the rest is very smooth. Inside of this bin, the top solid surfaces are also looking very smooth. And the inclined or declined surface, depending on how you want to look at it, inside of this part leading down into that bin area was also looking reasonably smooth. Now, obviously we will see some layer lines on this surface because again, it is on an angle, but for a part of this size, I was overall very impressed with the part quality. Next, I'm going to be printing this box for a snap latch case. And again, I know people skip through these videos to various random parts, so I will reiterate that I will be turning on the auxiliary part cooling fan by going into the filament settings, into the cooling section. I'm going to be selecting no cooling for the first 3 layers, and then I'm going to be turning up the percentage on the auxiliary fan speed to 100%. I did mention earlier in the video that you should be saving this as part of your standard print profile for PLA within Qidi Studio. I'm going to be leaving the rest of the print parameters mostly the same. I'll increase the wall loops to 3, and I'm also going to change the color of the filament. And despite the fact that I will be transferring these files to the printer over USB, the color change in the filament in the slicer will transfer over to the print preview on the touchscreen. Now I slice this file and take a look at the preview. The cross section overall looks pretty good. However, there are some parts, because this is a snap latch case box, where I want a little more reinforcement. Now I do not want to increase the infill across the whole part. So what I'm going to do is go back into the preview, right click and add a modifier. I'm going to add these cube shape modifiers, and I'm going to position them where the hinges will be on this snap latch case. And with those cubes selected in the object list, I can now modify specifically those objects. And what this is going to do is it's going to modify the actual part in the areas where it overlaps with the cubes. And so you can see on the bottom left hand side, I've increased the walls in this area to 4 walls, and in this area I've also increased the infill density to 40%. And this trick is not specific to Qidi Studio Slicer. This can be done in most modern slicers at this point, but of course for those of you who may be new to 3D printing, I just want to point this out, as you do not need to globally increase the wall count to 4 for the entire part, because that of course will increase your part printing time as well as the material consumption. I love using this method to specifically target areas of the part where I need some reinforcement and I do not want to increase my part printing time or filament usage. Now this part did finish successfully, and you can see that I did switch to black filament to match the color that I put inside of the slicer. But as you can see, there are some very visible defects here across these surfaces. It wasn't this bad with the gray filament, it's definitely worse using this black filament, and to make matters even worse, black won't hide it as well as the gray. The inside walls didn't seem to have been impacted quite as much as the outside walls, and the top solid surfaces looked very good. The first layer was also good, but again, these outer walls are plagued with this issue, which I'll show you how to fix very soon. But other than those horizontal lines, the rest of the part looked very good, and you can see that there are no other artifacts running vertically along the part, such as ringing or ghosting, which on some printers you might see with those large flat walls. Moving on, I now have a series of prints that we're going to perform for a mini project that we will assemble at the end. I've arranged the parts to be printed on separate build plates, organized by color, and we'll begin with the black PLA parts. There are a lot of parts in this project to print, so we're going to jump right to the final result of a lot of these prints. and the print profile that I used is just the standard 0.2mm PLA profile, and in most cases I'm just printing with 3 walls and 15% infill, and you can see one of the smaller parts here looks pretty good. And again, we've got a little bit of that banding horizontally, and then we have this part here, and you can see that it has a lot more detail, and a lot of those faces were built up on angles, and that's why you can see many of those layer lines, but it did come out looking very clean. This part was printed entirely without supports, and you can see there are some sections there that have bridges and overhangs, and they all came out looking very good. First layer was also quite good, and you can see on the back of this little jetpack, some of those overhangs were quite extreme, and I'm actually surprised that they printed just fine like that without any supports at all. And then moving on the build, we have one blue part. It's the only blue part in this build, and I'm going to be using some sparkling blue PLA for this particular part. And as with the other pieces, there's nothing particularly special about the print settings here. I've also elected to go with no supports for this part, as most of the overhangs are 45 degrees or less. This part took about an hour and a half to complete, and it looks very good overall. The walls are quite smooth, and a lot of that banding is being hidden by the fact that there is this sparkling effect in this blue PLA. You will have seen that in the hexagonal hole, there's a bit of drooping in the filament on the top of the hole, which was a bridge. And at first I was a little bit surprised to see that. However, then I realized that the hole was facing the left-hand side of the printer, and the auxiliary part cooling fan is blowing from the right-hand side. And you can see that hexagonal hole here is completely clean. And this is the one that was facing the auxiliary part cooling fan. So you can see how much of a difference that the part cooling fan makes. Therefore, if you have a critical feature that you need cooled that is a severe overhang or a bridge, make sure it is facing the right-hand side of the machine when you place it on your build platform. And after that, we've got these red pieces, and there's just an assortment of them. Again, no special requirements here in terms of infill, walls, or any other parameters. We're just going to send these right off to the printer for printing. This one was a nearly 3-hour print. And the one thing I'm really loving about the X4 printer is the reliability of the first layer. So far, it doesn't seem to really matter where I put the parts on the print bed. They all print very reliably. In the past, I've had some printers where there are some spots on the bed that might be warped, and even with auto bed leveling, for some reason, it just can't compensate. But again, so far with the X+4, it's been great. And these red parts look very good. Interestingly, these ones do not seem to exhibit the problem with that banding. And again, you can see first layer looks phenomenal, and there's actually some radiuses on these parts off of the first layer, like on that bow tie. And I'm surprised those printed as clean as they did, because a radius versus a chamfer requires a lot better part cooling as you get a severe overhang right at the bottom. But as you can see with this part, this one had a bunch of chamfers on it, and not surprisingly, these ones came out looking very clean. Bottom and top layers, as well as all of the holes, and even that transition from a square hole to a round hole, there was very little drooping. And finally, this part here is one of the feet of the model that we will be building, and you can see it also looks very clean, and all of the transitions from changes in directions are extremely smooth, no ringing, no ghosting, and again, top and bottom layers look great. For the next few parts, I'm not going to jump back into the slicer, because at this point you get the idea, and there's really no purpose of taking a look at those print profiles anymore. We've gone back to gray PLA for these parts here, and this is the back of the character's helmet that we will be building. This piece required a lot of support material along that long, gentle arch, and the support material separated from the part very easily. However, it wasn't very clean. I will have to clean that up with a hobby knife. I was using tree supports, which seemed like the most suitable support material for that gentle arch. And unfortunately, the rest of the part had a lot of that banding still visible, so I wasn't entirely happy with that part. However, some of the smaller parts, like these hands, had a lot of detail and some more complicated features, and these ones came out looking very good. And this is going to be critical for a lot of these small parts, because they are meant to snap together and fit together. And you can see that some of the slots and holes, again, are very clean on these small parts. So I don't anticipate having any problems with the assembly. And then after these gray pieces, we will move on to some yellow PLA. And the parts on this build plate are very small. There's even some of them that I wasn't even sure if I should attempt to print them, but I did scale up this whole project to 200% because I wanted a nice big model in the end. So technically, whoever did design this designed some of those very small parts to be printed in very, very fine detail. Perhaps with an even smaller nozzle, but at a 200% build, it was fine with the standard 0.4mm nozzle. Regardless, I was very happy with the quality of these yellow parts, and I thought they looked phenomenal. Now, between these yellow parts and the next color, I went to print something for a different project, and I made the mistake of initiating a color change before removing all the parts from the print bed, and I crashed the nozzle into those parts, and this tilted the print bed. It was a pretty violent crash, and you could hear the motors struggling, but luckily there is a way to fix this, and if you go into the tool section of the menu, you can actually reset the print bed, and it's going to walk you through how to do this. It will prompt you to use the on-screen button to unlock the motors, and then you can manually turn the lead screws to try and return the print bed back to a level position, or at least as level as you can get it visually. Once you've done that and you've clicked the next button, the printer will lower the bed back down to the very bottom of the platform. Now, I've sped these video clips up significantly, but you can see by running the print bed back down to the bottom, it has re-squared that bed with the rest of the printer frame, and now it's preparing itself to go back into the manual bed leveling procedure. So I followed those instructions on screen and manually leveled the bed, and this is not something that you would have had to do when you first got your printer because it should have been calibrated from the factory. When you first get your machine, you're only prompted to do the auto bed leveling, and I guess the assumption is that somebody at the factory has already done the manual bed leveling for you. And I was of course under the same assumption, and I never actually bothered to check it. However, what I found after having to do the manual bed leveling again myself was that this significantly improved the part quality and completely got rid of that banding that I was seeing running horizontally across a lot of these flat surfaces. And because I had crashed the print head into those parts and then skewed my print bed, and this is what prompted this whole thing, I obviously can't go back in time and verify whether or not they did a good job from the factory manually leveling that bed, but I'm going to go ahead and assume because it got rid of this problem that this was the cause of the problem, and perhaps they are not doing a very good job at the factory of manually leveling the print bed. And so if you do pick up one of these printers, then I would highly recommend that you go through this process yourself when you first get the printer, hit that reset platform button, and then go through the manual bed leveling process and make sure it's dialed in really, really well and carefully. And I don't want to place all of the blame perhaps on the factory. Maybe the bed got knocked loose during shipping. That's also a possibility. I know a lot of couriers, they do not handle these things gently. But that process of doing it manually will only take you about 10 minutes, and I think what it's going to do is it's going to relieve the auto bed leveling process from having to compensate significantly for a poorly leveled bed. And so for a part like this that I'm about to remove from the print bed right now, previously, before I had done this leveling process, we would have seen a lot of horizontal banding. But here you can hopefully see that it is completely gone. And I'm obviously very happy about that because now the part quality is going to look fantastic going forward. However, I am a little disappointed that I did have to discover this by accident. Reflecting on what happened here, I feel like I've gotten a little too complacent with how good a lot of these modern 3D printers have become. And it's easy to forget to return to the basics when you start having problems and then just end up writing off the printer as something that prints mediocre. When in reality, if you just put in a little bit of work into troubleshooting some of these problems, you can solve them and then you end up with something that prints exceptionally well. And as you can see with this part here, this is a very large helmet, and this took several hours to print, I think upwards of 8 hours. There's a lot of tree support on it, and all of this tree support material came off a lot cleaner than it had previously when I was experiencing those banding issues. So again, when you're printing with support material, there's a very small gap left between the top interface of that support and the rest of the part. So if you have a bed that's warped or leveled incorrectly, perhaps you're getting an interface that's actually touching the part, and that makes it messy when you remove it. But now I'm seeing this support material come off quite a bit cleaner. And after that helmet was printed, it was on to the assembly of this entire project. And you may be able to see now what we're looking at building, and this is going to be a Gundam Wing style Hello Kitty. And some of these very small yellow parts that I'm pointing at right now were some of the parts that I had mentioned earlier that were very small. Had I had not scaled this model up to 100%, perhaps those parts would have only been 1 layer thick at their original 100% scale, but at 2 layers thick, I was able to print them, and I was just kind of surprised they never got knocked off the print bed. The rest of the model is going together very well. I had very little issues in terms of fitment, so again, all of the parts came out very clean, and I'm able to just glue them all together with some simple hot glue. Over the years, I've watched a lot of people build things online with PLA 3D printed parts, and a lot of times they're using super glue or some specialized formula glue for PLA specifically, but I've never had an issue with simple hot glue, at least not when putting things together that are big enough where it will accommodate the hot glue. Now, if I was putting together some very, very small parts, then I might turn to some super glue or gel type super glue for very fine assembly. But if you haven't tried it yet, just go grab your hot glue gun and you'll find that it sticks PLA parts together very well. And if you guys are looking for this model, I will of course put a link to it in the video description down below. Shout out to the designer of this thing because they did an amazing job of sizing all of these parts to fit together very well, and the amount of detail is very impressive in this model. There are actually a lot of pieces in this model, and some of the parts go together in such a way that allows some of the limbs, like the arms, to articulate, whereas the legs will be fixed in place. But overall, it is very well thought out, and if you do visit that link to download these parts, you'll also see that the designer of this model put a lot of time into the instructions. And for a model of this complexity, I would say that is completely necessary, and I'm just really happy they did such a good job with that. Let me know in the comment section if you guys enjoy mini projects like this when testing out some of these printers. Feel free to leave links down there to your own projects, as well as other models that you would like to see me print in the future when I'm testing other printers. I'm sure you guys have some great suggestions for models that would highlight or challenge a printer's capabilities. Overall, I thought this one was a pretty good example, and the end result was amazing, especially considering that at the time of this video, Qidi did not yet release their Qidi box for multicolored printing, so all of these parts could be printed in single colors and then of course assembled at the end to look this good as a multicolored part. Perhaps in the future, Qidi can send me the Qidi box and we can test out this printer with some actual multicolored pieces. But for now, we're going to move on to one more material, which a lot of us print with, and that will be PETG. I personally like to use PETG for some more of my outdoor projects because of its resistance to UV light. But one of the challenges of printing with PETG is the fact that occasionally the first layer can start to lift or warp and separate from the print bed. In the past, I found that it was trickier to print with PETG than it is on more modern machines, so up till recently I haven't really had too many problems with it, and I fully expect here that with the built-in PETG profile within Qidi Studio that we should be able to successfully print PETG without too much fuss. And so this bracket here is something for another one of my Google Nest security cameras that I will be mounting outdoors. And this is one of my more earlier prototypes, so I only printed this one with 3 walls, and I did use 20% infill, but perhaps for the final version I'll go with even more walls for added strength and durability to ensure that it lasts outdoors for many years to come. Now this print took about 5.5 hours to complete, and I was very closely monitoring it during that entire time just to make sure that I wasn't seeing any of the first layers peeling off the print bed and starting to warp. And this is a very bright and shiny white color. PETG tends to be quite glossy, and so we're going to look at this under a different light to hopefully see more of the details. The top surface here is stepped. As you can see, it's on an incline, and that's why you're going to see a lot of those layer lines. Otherwise, all of the other surfaces looked very smooth and uniform. As I mentioned earlier, after doing that manual bed leveling procedure, all of those strange artifacts running horizontally across the walls of the part have completely disappeared. First layer was absolutely perfect, and if we look at it at this angle here, again we can see that none of it, not any of those corners, which most of them were actually square, started to peel off the print bed. If you are experiencing lifting corners with PETG, sometimes it does help to radius those corners, but in this case, I did not have to do that whatsoever. And these faces that I'm pointing to up here right now, those were all completely printed on top of support material, and they came out looking very good. Now, I did revise this part, and I wanted to print it in the final version in some carbon fiber PETG. And so I actually used the exact same print profile, and you can see these parts here in the black carbon fiber PETG. Now, carbon fiber adds a really nice look to the PETG where it takes away a lot of that glossy shine, and you end up with a more semi-gloss sheen. This is actually one of my favorite materials to print, and I find that the top solid surfaces look the best with carbon fiber PETG, not just on the Qidi machines, but even on several other machines that I've printed with. I'm not sure what it is, but top surfaces, I don't know if it's the carbon fiber, but it really makes them look very smooth and uniform. It also does a really nice job of hiding layer lines, as you can see on this face here, which was of course printed on this pretty steep incline. So if you have not yet printed or attempted to print with carbon fiber PETG, I would definitely encourage you guys to go check that out and give it a try. It's now easier than ever to print some of these more advanced materials on modern printers, especially with printers like this Qidi, where the nozzle will heat up to 370 degrees, and you've even got an active heated chamber, which can maintain an internal temperature of 65 degrees to prevent more advanced materials from warping. I didn't have to use that active heated chamber with the PETG, but I do have some future projects where I do plan on using it and putting it to good use, perhaps with some more advanced materials, such as nylon or even some PC-based filaments. And drawing our attention back to this part on the topic of warping, you can see again from this angle here, none of those corners lifted or warped, despite the fact that we were not using the active heated chamber, as it's really not necessary for this PETG, even combined with carbon fiber. Everything else on this part looked pretty exceptional in my opinion. You can see some signs there of some waviness, but you can't actually feel it, so I'm not sure what's causing that visual variance, and I'm just overall very happy with this part. So that's it now for all of the example prints, and my overall experience with this machine has been quite good, especially after fixing that issue with those banding artifacts that I showed you how I fixed by resetting the platform and redoing the manual bed leveling. The quality and consistency of the parts has increased substantially now, and that is obviously a great thing, and it provides me with more confidence in this printer, using it for my own purposes, as well as recommending it to other people, of course. And I'm now more eager than ever to try out more advanced filaments with this machine. As you had seen in this video, I only really used PLA as well as PETG, but I'm looking forward to using some PC-based materials for some upcoming projects that I have that I'll hopefully produce some video content with. And I have some car-related projects that I'd like to show you guys, and I think I'll be using the Plus4 printer for some of those projects. So you'll probably see this appear again in some of those future videos, so stay tuned for those. Also, with the new release of the Qidi box, I'll probably reach back out to Qidi and see if they're willing to send me one, because of course I'd be interested in trying that out with the Plus4 machine, and that could also be some future video content that you guys will not want to miss. Now, although my experience has been overall very positive, I do have some things to bring up. The first one being the Wi-Fi connection that I mentioned earlier in the video. I have not been able to get that to work to date, and I'm not entirely sure that I can blame that entirely on the Plus4 machine, because I have issues with my Google Wi-Fi network. It's a dual band system, and I've got other printers from other manufacturers as well as laser engraving equipment that just does not like this network. So it's probably more related to that, but of course I have to mention that I just could not get that to work, which is very disappointing because of course sending files wirelessly versus the USB stick is so much more convenient. But on the topic of the USB stick, the other complaint that I have is that when I put files on there, they're just G-code files, and the print preview on the touchscreen comes up. It's very, very slow to load. And this makes it frustrating and clunky to scroll through all of the different files, because of course it's lagging and trying to bring up all of those print previews before you can progress to the next page. So if you have a whole bunch of files on your USB stick, the experience there of trying to get a print up and running is slow and it is clunky, and I wish that they would improve that. However, on a more positive note, the hardware on this machine has been very reliable for me, and I haven't had at least from what I can recall, a single failed print. Other than that first print that I showed you guys in this video where I had to prematurely cancel it because I was still learning this machine and I didn't have the auxiliary part cooling fan enabled. That was the only one that I can, like I said, recall where I've had to actually cancel a print, haven't had any fail, no prints knocked off the print bed, I haven't had a clogged nozzle, I haven't had a jammed hot end or any issues with the extruder. This printer has otherwise been very bulletproof for me. I've put a lot of miles on my older QIDI X+3 machines, and those have also proven to be very reliable with just the regular 3D printer maintenance required on those machines. So I'm expecting a lot in the future out of this X+4 machine, and hopefully it also proves to be very reliable in many more months to come. So that's it. If you guys have any comments or questions, please put them in the comment section down below. I love hearing from you guys and I really value your feedback. I'd love to hear if you have any suggestions for files to print, projects to take on, or other machines or equipment to test out in future videos. And if you guys are looking to support my channel, as always, check the video description. I've got links in there to the Qidi PLUS4, as well as some other stuff that may have appeared in this video. Those links help support this channel, and you can check out my website, embracemaking.com, where you might find something useful or interesting on there. And obviously, using my website will directly support me. I would love it if you guys go check that out. Thank you so much for watching right to the end. See you guys in the next video.